here with John Carmack of id Software. We're going to ask him some questions, user-submitted questions, as well as some of our own, focus on hardware and technology and those types of things. Thanks for joining us.
Welcome.
One of the interesting ideas that's come up is as game engines have evolved into these much more complex things, as obviously you are well aware of, how are mathematics involved in this more so than just what we previously did with management of hardware in computers, right? So how important are mathematics in these engines now as opposed to just...
So it's interesting in that I have had my math background overstated. For a while there on our company press information, it said something about me reading math textbooks all the time, and I'm really not that much of a math geek. We've had a few people come through id that are much more versed in advanced mathematics. I was able to do all the things that I needed to do just by having a very strong, very applicable knowledge of basically high school topics, going through Algebra 2 and trigonometry, a little bit of calculus on there, but knowing how to apply them to situations that weren't in the textbook and actually how to use them for a problem that comes to you rather than something that's sitting down on the test is what's really important. Now, we use some more sophisticated mathematical solvers, numeric and iterative methods for some of the physics, collision response, things like that on there. And as you get to simulations, it gets a lot more where people start looking at Navier-Stokes equations and things like that to do, turbulent fluid flow simulations. And you can throw arbitrary amounts of compute horsepower and analytical knowledge at things like that. But I do kind of keep coming back to time slice things far enough and everything's linear and you can apply linear technologies to it. But when we do get people like applying for jobs on there, an advanced math background does say a lot about a person to be able to get through working at those high levels of abstractions. And I've certainly had people working for me that I know are far beyond me in levels of what they can do analytically with math. But I do always come back to, well, you can chop everything up again and do it all with discrete approximation methods on there. And many times what you can spend hideous amounts of blackboard space doing analytic solutions for winds up being solved much, much more easily with Monte Carlo iterative methods.
Cool. Focusing back on the hardware side of things, previous years in Quakecons even, we've had debates about what GPU is better for certain game engines and certain titles and what features they do better, NVIDIA and AMD. You have said previously that like CPUs now, you don't kind of worry about what features they have. They all kind of do what you want to do. Are we at that point with GPUs? Is like the hardware race on GPUs over or almost over?
I don't worry about the GPU hardware at all. I worry about the drivers a lot. Because there is a huge difference between what the hardware can do and what we can actually get out of it if we have to control it at a fine-grained level. And that's really been driven home this past project by working at a very low level on the hardware on the consoles, and then comparing that to these PCs that are, in many cases, true order of magnitude more powerful than a PS3 or something, but struggling in many cases to keep up the same minimum latency. They've got tons of bandwidth. They can render, at many more multi-samples, multiple megapixels per screen on there, but to be able to go through the cycle and get feedback, fence here, update this here, and draw them there, it struggles to get that done in 16 milliseconds, and that's frustrating.
That's an API issue, API software overhead. I mean, have you seen any improvements in that? DX11, multi-threaded drivers, those types of things, are those improving that, or is it just still not keeping up?
So we don't work directly with DX11, but from the people that I talk with that are working on that, it might be some improvements, but it's still quite a thick layer stuck between you. There's some work that like NVIDIA has done some direct hardware address implementations where you can bypass most of the OpenGL overhead, other ways to bypass some of the hidden state in OpenGL. And those things are good and useful, but what I most want to see is direct surfacing of the memory. It's all memory there at some point, and the worst thing that kills rage on the PCs is texture updates, where on the consoles, we just say we are going to update this one pixel texel here. We just store it there. It is just storing through a pointer. While on the PC, it has to go through the massive update fraction of a texture update routine. And that takes, it's not hundreds, it's not even thousands. It's like tens of thousands of times slower if you just want to update update one little piece of it.
Right.
Now you amortize that overhead when you start updating much larger blocks of textures.
Right.
And AMD actually went and implemented a multi-texture update specifically for id Tech 5 on there. So you can batch up and eliminate some of the overhead by saying, well, I need to update these 50 small things here, but still it's very inefficient. So I'm hoping that as we look forward, especially with Intel, with integrated graphics, it is the main memory. There's no reason why we shouldn't be looking at that. With AMD and NVIDIA, there's still issues of different memory banking arrangements and complicated things that they hide in their drivers. But we're moving towards integrated memory on a lot of things, and I hope we wind up being able to say, give me a pointer, give me a pitch, give me a swizzle format, and let me do things managing it with fences myself, and we'll be able to do a better job.
It seems like AMD has been talking a lot about the future of their CPU, GPU, what they're calling the APU combination. Have you spent any time with that?
So, I mean, it's important to separate a little bit. The current generation Fusion parts are really still a separate GPU and a separate CPU connected on the die with better or worse interconnects on there. But their vision is integrating them much more tightly, such that they share cache hierarchies, share address spaces, share page tables, and I think it's almost a foregone conclusion that eventually that's going to be the dominant sort of architecture in the marketplace, because there are these strong forces about how we're getting more shrinks on the dies, we can stick more things on there, it's going to just pay to integrate that. You're not going to be able to put as many transistors towards that if it's a dedicated chip, but you'll pick up a lot from this tighter integration. There's significant cost benefits, and it's Intel's also doing a lot better in terms of their integrated graphics parts. They used to be the butt of jokes on the Intel integrated graphics, but they've taken a couple steps now which are fully competent parts. The drivers still aren't very well tuned, and the bandwidth's not great yet, the total raw performance, but they're pretty much at feature parity, barring some quality issues on there, but it's close, and they get better each time, and this will be one of those things that's going to sneak up on people where all of a sudden the stuff that they got free with their CPU is all of a sudden good enough to basically run the games they want to play on there. And I have high hopes that because it is all integrated memory, that Intel will be able to lead the way a little bit with surfacing like direct access to some of these, because that will give them this opportunity to sometimes take console developers who are used to this lower level access and maybe have something, shock of shocks, run better on an Intel integrated graphics part than a much more expensive Intel or NVIDIA or ATI card that has all the layers of driver overhead in it.
Does that kind of lead us to single platform across consoles and PCs then? Is that, future consoles, maybe this next iteration in 2013, 2012 is kind of already set in stone where you're at one processor across all these types of devices, or at least where you get the same type of access across all of them?
It's interesting in that if you asked us a couple years ago, there was, when we surveyed the field, there was this thought that would Intel's Laribee be the one thing to rule them all that could go off and sweep the platforms on there? And of course it turned out to not meet performance expectations on there. And it was an interesting architecture, but a lot of us were cautioning from the very beginning that, don't underestimate what the fixed functionality of the GPUs provides them on there. And if people want to draw polygons made out of vertexes containing fragments on there, hardware that's kind of built around that is going to outperform hardware of a more general purpose nature. But so right now, I think it's clear. I would be very surprised if all the major platforms came out with a common processor GPU architecture. I think it's obvious that there will be at least strong contenders with ARM cores mixed in with conventional GPUs. I hope that they don't try to push cell architectures again on there, because there's a lot of reasons why the peak performance is great, and there are cases in Rage where a PS3, if you're in an instance level where you've got a lot of main memory, so a lot of things are cached in RAM, the extra horsepower of the cells will let it transcode them into graphics memory faster than, much faster than a 360 and faster than all but the very most extreme PCs on there. But it's a pain in the ass to take advantage of it that way, and for the cases where we didn't have all that buffer in memory, it winds up being more problematic.
You mentioned ARM in that. Do you think that they are, obviously your experience with iOS and programming for that, is that architecture capable of doing the type of performance necessary for consoles and even modest
NVIDIA
PCs?
is basically re-implementing their very own custom ARM architecture. So there's a big distinction between when you say like an instruction set or an architecture specification and the physical implementations of it. And there's lots of, heck, x86 spans a huge range of capability on there. So there's no doubt that ARM can handle a lot of that. What I would worry about a lot is that they're just beginning to push through to their 64-bit transitions, and any next-gen console's got to be a 64-bit platform. And of course, the PS3 is 64-bit in many ways, but it cuts off the upper half of the address space in this very strange decision-making process on there. So we don't know how ARM's going to fare as 64-bit processors, but lots of companies have been through all of this. Apple has a ton of experience migrating across all of that, and I'm sure that they're working closely. But how close, like Apple, ARM, and NVIDIA are working together on different things is an open question. But ARM is more likely to make a dent in it than x86 just because of the x86 business model on there, where desktop CPUs just cost so much more. If you've got PowerPC or MIPS or especially ARM now, it would seem likely that ARM has a better ecosystem than PowerPC, and that there would be some good sensible reasons to go with that.
Okay, all right. A couple software questions now. A couple years ago when we last talked, we discussed ray tracing. At that time you didn't think it was going to overtake anything in terms of rasterization, actual engine use. You were more interested in ray tracing for data structure and accessing, I guess. Has anything changed over this time period now?
Yeah,
we don't see ray tracing engines yet. But
I spent quite a bit of time on ray tracing in the last year and a half or so. I spent a bunch of time with OpenCL figuring out what I could do with that and doing a real ray tracing engine. And I made some pretty cool stuff where there's a few experiments that I wanted to get results on. One was trying to say, well, what if you had a hybrid engine and you just ray trace the specular reflections on there? How would that look? So I did that, and it turns out ray tracing off of a bump mapped surface looked god-awful bad with a single ray. You really need to throw, at least 10, maybe 50 rays to wind up making that look really good. And it was neat to have this overlaid mirror surface in a lot of things, but that clearly wasn't a near-term function for this. And then using it for just raw replacing rasterization on there, I got a somewhat mixed result on that, where it was a little bit closer than I thought it might have been for tracing into a static scene on there. And one of the things that I wanted to do that I finally got to test, that I've been talking about for years, was with rasterization, like we aim for 60 frames per second on Rage, but that means we have to keep a cushion, and we dynamically adjust our resolution, but we never get 100% utilization on there because we always have to leave a little margin in case we misestimate on there. But I've always wanted to have a technology where you could just keep throwing rays or rasterizing or something, and when you're at 60 frames per second, you just use what you've got. So you can really hard cap the stuff there. And I did a ray tracing engine that took advantage of that, where like on the system I was testing it on, there's a Fermi NVIDIA card on there. I could run 720p ray trace in most of the cases at around 60 frames per second, but in certain areas it would start falling off on there. But I had it set up so that it could just stop early and include, I could do it two ways. Either I could have it be a lower resolution image come up from that, or I could have it include frames from somewhat further back, so it sort of turns into motion blur on there. So I would do per pixel jittering in both spatial domain for anti-aliasing, temporal for motion blur, and then capping it in the different ways, and that worked really well. But the interesting thing is, whenever you see people make demos about things, it is not appreciated what a large gulf there is from a tech demo to something that's going to show in a game. So like I have this 60 frames per second 720p ray tracing engine here, but it's dealing with static models on there. It doesn't have character animation or anything on there. You could spit out a depth buffer and use a hybrid engine on there to do that. But also the fact that it runs 60 frames per second at 720p, that sounds impressive for a ray tracer, but if you were just drawing drawing that same thing with no fragment shaders on there using a traditional engine on there, it would be running 1,000 frames per second. So we do all of this other stuff. Once you throw your particles onto it, your post-processing, and all of your character animation, all that, that core part that people are like, woohoo, great detail at 20 frames per second or something, that is a huge gulf between that and something that can be a part of a major AAA engine on there.
Okay.
But on the other hand, we've converted all of our offline processing stuff to ray tracing, where for years the back-end megatexture generation for Rage was done with, we had a GPU cluster where we had a rack of systems that had NVIDIA cards in them, and that was such a huge pain to keep. You'd think computers and graphics cards, they're all supposed to be deterministic, but it was an amazing pain where like one system would be having heat problems and would be behaving weird. Even though we thought they had identical drivers, something would always be wrong on render farm 12. And whenever we wanted to put in new features, it was like, okay, writing new fragment programs to go into this. Now, granted, I did this just when CUDA was in its infancy, and if I did re-implement it with OpenCL or CUDA, we wouldn't have some of these problems. But when I converted all of these over to ray tracing, there was a number of things that got a lot better. Things that we deal with shadows and reflections that have to be approximated in these ways that we're just so used to doing. We've done them for decades in rasterization on there. But you sometimes forget how big of hacks these are. And to be able to just say, no, I really just want that ray and tell me what it hit, not do a projection with feathering shadowed edges and whatever the heck else we're doing there. So much of the code got so much easier, and if it's a choice of, now that we have these awesome multi-core x86 CPUs where we can get 24 threads in these commodity boxes on here, it's true that one GPU card can do more ray tracing than one 24-thread x86 box on there, but it's not multiples more, and if it's just a matter of buying more $2,000 boxes over here, it makes the programming, development, maintenance, upkeep, all of these things much better. So while everybody in high-performance computing is all rah-rah GPUs right now, I've kind of come full circle back around to saying the fact that we can get massive amounts of x86 cores and threads in here, it won't win on like flops per watt or flops per volume on there, but in terms of results per developer hour, it's much better.
Just different types of efficiency then.
And when you're developing, it's perfectly fine for us to spend hundreds of thousands of dollars in our back room to go ahead and make things better for that. It is a different question where if every consumer has some graphic processor of some kind, we're going to do whatever it takes to max that out, because you can't tell everybody to go out and buy lots of x86 boxes. So there's, but it's interesting the difference between the design decisions that you make for a consumer target versus for a development target on there.
Interesting. Now, a lot of I guess one of the interesting topics going around in the graphics world now is the idea of infinite detail engines, voxels, these types of things. I was curious if you had, I know you've played around with voxels, you've written like little voxel engines and that kind of stuff. What do you think about this debate about the possibility of an infinite detail engine?
Okay, for one thing, I think it's important to separate the notion of infinite detail from voxels, because you can have voxel, many of the voxel engines that I've written have been at finite coarse levels of detail. The fact that you can instance detail in them is, in many ways, it sounds awesomely cool, infinite detail, but if we look at all of the trends that we've been doing with, that Rage epitomizes in many ways, procedurally generated detail is usually not what you want. This has been an argument going back for decades on here, where now's the year of procedurally generated textures, geometry. We've heard that for a decade, and it never has come true. What has won is being able to manage the real data that we want, because proceduralism is really just a truly crappy form of data compression. You have the data that you really want. Proceduralism makes you something that might resemble what you really want, but it's a form of extraordinarily lossy data compression that lets you produce something there. And that really is orthogonal to voxels. You can do procedural, infinite detail is basically proceduralism, and you can do that with polygons, voxels, atom splats, whatever on there. So they're tied together now with people talking about the recent demo that came out, but they're really orthogonal topics. And I don't think that the notion of infinite detail is actually all that important. It's more important to be able to get the broad strokes of the artistic vision in there. And if you take uninspired content, if you can go look at it down to the molecular level, it's still uninspired content, and it's not really going to make a big difference. Now, what's potentially useful about voxels is it allows you to access them in a certain way that may be more efficient than, say, like a RISE pipeline of dicing polygons and doing displacement mapping and things like that. They're both ways to give huge amounts of geometric detail, which is obviously the next frontier. After we uniquely texture everything, we want to uniquely geometrify everything on there. We all want to kind of go there, but it is also important to realize that I was showing megatexture demos 5 years ago. It took 5 years for it to turn into a production quality game on there. And you could make a cool, flashy demo of like, look, isn't this amazing? We can stamp down stuff and everything looks totally different. There's no tiling. We can use procedural information to generate all of this. But there's a huge amount of work that goes into building robust production quality systems that you can build real game worlds with this. So I did, I've revisited voxels at least a half dozen times in my career on there, and they've never quite won, but I am confident in saying now that ray tracing of some form will eventually win, because there's too many things that we suffer with rasterization especially for shadows and environment mapping, that we live with hacks that ray tracing can let us do much better. And for years I was thinking that traditional analytic ray tracing intersecting with an analytic primitive, that couldn't possibly be the right solution, and it would have to be something like voxels or metaballs or something. And I'm less certain of that now, because the analytic tracing is closer than I thought it would be. So I think it's an interesting battle between potentially ray tracing into dense polygonal geometry versus ray tracing into voxels and things like that. The appeal of voxels is that it's like bitmaps, and that a lot of things can be done with filtering operations. You can stream more things in, and there's still very definitely appeals about that. And you also start looking at them as like little light field transformers rather than these hard surfaces that you bounce things off of. So I still wouldn't say the smart money's on voxels, because people have been trying it for a long time. Lots of smart people. It's possible now with our current modern generations of graphics cards to do credible full-screen voxel rendering into hyper-detailed environments, and especially as we look towards the next generation, I'm sure some people will take a stab at it. I think it's less likely to be something that is the cornerstone of a top-of-the-line AAA title, but it's in the mix. It's not a foregone conclusion right now.
Now, in the near term, what are your thoughts on like tessellation? Does Tech 5 implement any tessellation?
No, we don't have any tessellation. Tessellation is one of those things that bolting it on after the fact it's not going to do anything for anybody really. It's just it's a feature that you go up and look at specifically to look at the feature that you saw in the bullet point, rather than something that impacts the game experience. But if you take it into account from your very early design, and this means like how you create the models, how you process the data, how you decimate to your final distribution form, and where you filter things, all of these very early decisions, which we definitely did not on this generation. I think tessellation has some value now, but it is interesting that there's a no man's land we're right now in polygon density levels. We're sort of at a no man's land for tessellation, because tessellation is at its best when you're doing a RenderMan-like thing going down to micro polygon levels. And current generation graphics hardware really kind of falls apart at the tiny levels, because everything is built around dealing with quads of texels, so you can get derivatives for your texture mapping on there. So you always deal with 4 pixels, and it gets worse when you turn on multi-sample anti-aliasing, where in many cases, if you do tessellate down to micro polygon sizes, the fragment processor may be operating at less than 10% of its peak efficiency. So when people do tessellation right now, what it gets you is smoother things that approach curves. You can go ahead and have the curve of a skull or the curve of a sphere. Tessellation will do a great job at that right now. It does not do a good job at the level of detail that we currently capture in normal maps. The tiny little bumps and pores and divots and pebbles. Tessellation is not very good at doing that right now, because that is a pixel level, fragment level amount of detail. And while you can crank them up, although current tessellation is kind of a pain to use because of the fixed buffer sizes on the input and output, it's a significant amount of effort to set an engine up to do that down to an arbitrary level of detail. And current hardware is not really quite fast enough to do that down at the micro polygon level. So it's almost like procedural data, where we've heard tessellation is going to be the big thing since the NP patches from the ATI stuff on there. And there's reasons why it never caught on, because in the early days of shells on things, when you say, well, we've got a Bezier spline or a NURB or something like that, what we would find is that, well, if you're going to have this net of 16 vertexes around here, you can do cooler game art by making that 16 vertexes for triangles. You'll have cooler protrudences rather than your smooth Gumby shape on there. Now that we've got enough ability to go ahead and do texture sampling in there and do real bump mapping, it becomes interesting from a content point, but we don't quite have the power to do the entire world. You can run a character down like that with current generation stuff, and that's probably useful directions, but you can't yet go ahead and render your 2 million pixel world at sub-pixel micro-polygon triangles at certainly 60 frames per second on there. But that's the type of performance we're going to get that no matter what. And I think that the smart money bet for next generation consoles on there, early on, they're just going to be hyped up versions of our current sort of technologies. But when people build technologies from scratch for that, the smart money would be on a tessellation based, all the way down to micro-polygon level, with outside bets on voxel ray tracing hybrid type engines.
I think you mentioned in your keynote yesterday that Rage wasn't going to have support, or in the Q&A wasn't going to have support for Eyefinity, surround, and the thing. What is your long-term view on those types of technologies, multi-displays, 3D technologies, how they can differentiate from consoles? Is that something that you think is going to catch on or should catch on?
So it's a lot of these things. Historically, id was known for having a lot of patches for weird, quirky things on there, and I hope we can kind of follow that up with this, where to get the game out the door. And the great thing is we do have another month to go on the PC, because the console cert process in manufacturing takes longer than the PC. So the PC is at parity with the consoles now. You crank up the resolution, the anti-aliasing, and all this, but we hope that we can do some extra things for the PC, but not much is going to make it in for the initial one. But I have research engines that I'm working on that I'm hoping we can release, if not as official patches on there, maybe as novelty patches, which is what I used to do back in the GL Quake World days on there. It's not clear exactly what we're going to have with that, but I've promised myself that after Rage is done, I get to buy a bunch of toys on the PC. And I've got my Kinect SDK, I ordered a new head-mounted display, and I probably will set up the multi-monitor stuff and run through all of that. Because a lot of that it's legitimate research where I need to gauge how important are these things that we can do. What extra benefits do you get by adding these additional layers? And I've been saying this for years, but my money still is eventually on direct ocular scanning and I think mobile devices will probably be the thing that drives it home, where we're carrying supercomputers around in our pockets that are just crippled by lack of I/O devices on there. And I think that once you go ahead, you get the little thing that goes up there and clips onto your glasses and laser scans into your eye. That gives you very high resolution, and I really strongly believe at this point that the big impact changes where people are going to say, wow, this game is so much different than what we've had before, is going to be from I/O devices. It's going to be when you can have, because we've got rendering ability to do this for sure. We can do incredible virtual reality world rendering, but if you're just looking at it on a TV set, there's a limit to what the extra quality will do. But if we can get down to below the perceptible response level of looking around and experiencing the world, even if we took the worlds that we just had today and we were able to get that extra level of immersion, I think that's going to make the games really go to the next level. But it's not clear what that is. Is it a consumer head-mounted display? Is it something else where you've got just more freeform displays looking around at things? I don't think that we've got a big enough buy from 3D displays or even head-tracked 3D displays on there, because you're still looking at a window into the world. I mean, I do think that the real big step has to be from something that attaches and moves with you.
Interesting. Something that came up. Rage is going to be, you're targeting 60 frames per second. Is there any kind of benchmarking testing modes you guys are going to implement for the PC?
So that's something we don't have in yet, where it's, in fact, we need to implement at least in the next month some little micro benchmark just to tell if when you crank the settings to a specific level, what quality it is. So we don't have like time demo runs through all of this, but we probably will have some somewhat artificial scenes set up just to benchmark in the video settings that will probably spit out a number so you can see, can I crank up more anti-aliasing or down on this? But again, it's frustrating on the PC that while you might have the hardware capability to run at these extremely high resolutions and all of this, we get tripped up a lot in the drivers with the texture management and some of the fencing and other resource management.
Okay, all right. In Tech 5, in terms of licensing, what do you guys have planned in terms of tools for developers?
So it's a high-level corporate decision that there's no external licensing. Only companies in the ZeniMax family have access to the Tech 5 technology.
Okay.
And there's a couple other teams that are working with it right now. For the user community on there, all of our tools are only available in the 64-bit version. We ship the Win32 version, which we treat kind of like a console platform, but we will be releasing the 64-bit version after the fact. But honestly, it's going to be a limit to what people can do with it because there's so much infrastructure that goes into building a mega textured world on there. And I suspect we'll have some people that, there will be one or two people that go through the trouble of figuring out how to really build a mega textured world or do some of the stamping effects on there. But mostly it's going to be for like changing gameplay stuff. You can set up new layers, you can build a new multiplayer layout on there, build your nightmare difficulty levels going through it. Yeah. But it's unfortunately just, there's too much in the back end for it to, like I mentioned, there's a terabyte of source art that goes into building the game on there, and we're certainly not going to be pushing all of that out for download.
Okay. One last question then, kind of quickly, in terms of now that you're part of the ZeniMax family, you've been seeing what the developers at Bethesda have done with Skyrim. How has that kind of affected what you guys have done with Rage and what you think you'll be doing in the future?
So there were a few things that, the great thing at the ZeniMax is we have these Christmas get-togethers where all the teams get up and they show their product, just the family, not worrying about how it's going to be taken by the press or public on there. And it's really neat in there to be part of a family like this, where it's not it against the world. It's it's our team here, and we can cheer for Skyrim and different things there. But there have been some specific things that I've looked at that I've hearing Todd Howard talk about some design decisions in Skyrim and some of the thoughts about what an adventure game is and what people get out of this. There are some very specific things about how you feel about your loot and your items and how you want to fondle your stuff and how you scroll through and look at the different things that a lot of it are things that I have as specific bullet points for Rage 2 and things that I want to go into here. Is like, I want to do a better job on this. I want to play this up more. Because they are different genres, and there are things that you choose to do in one way. It does detract from certain other aspects. But there is low-hanging fruit here that's just better, making items cooler, making more things that you can look at, and you can ignore things that you can completely ignore if you don't care about that. But if that's your thing, you can go in there and drool over all of your stuff and plot your acquisition strategy for all of this. We can add this level of things to our game, and we've started to with Rage, but there's a lot more we can get out of it. And we can add this, and it can make the game much better for lots of people. And some people might not even notice that extra stuff is there, but for some people it's going to double the fun that they have in the game. And it is great to basically be here with masters of the craft, where there's a lot that we can learn from them, and it's a good relationship.
Cool. Well, thanks for talking with us.
All right, thank you.